What I'm going to attempt to do now is go through two more proving trig identities and show you some of the techniques that you haven't seen yet. Although I think this one right here is a technique that would make sense because we've seen the identity used over and over again, and that's the whole idea of using a Pythagorean identity. And when you look at the left side of the equation, our denominator contains 1 minus sine x. And we can get the Pythagorean identity here by just going and multiplying by 1 plus the sine of x. But we don't want to change the value of the fraction, and so we have to multiply by 1. And so we just also make our numerator the same thing. Parentheses around it to kind of remind us that it's a factor. And so as we do this on the left here, my bottom becomes 1 minus sine squared x. And immediately I know that next step is going to be cosine squared x. What do we have on the top here now? Well, I could distribute here, and I think in a lot of cases I would distribute when I see that parentheses. But when I look down 2 steps here, I see cosine squared x. And so that can cancel out any factor of cosine. And so I'm just going to keep this as is. In fact, I'm going to, I would write that in here. But why do it twice? I'm going to save myself a little time here and just come down and write my numerator as 1 plus, that should be a plus there, 1 plus the sine of x times the cosine of x. The other thing I'm forgetting to do here, I should be carrying down my equal sign, because my ultimate goal, I want the left hand side equal to the right hand side. Don't ever forget what your goal here is. Now, at this point, I see I can cancel out this cosine x, cancels out one of those. And what I'm left with here on the bottom, well, on the left hand side I should say, is the ability to go back in, and since I just have a single factor in my denominator, I can write this as a sum of two fractions. And so this would be 1 over the cosine of x. Now remember, if I'm going to take this single fraction and write it as a sum of fractions, you have to have a common denominator, which in this case is our cosine x. Second fraction is going to be sine x over cosine x. And now I can see what my final step is going to be, because 1 over cosine x is my secant x, plus sine over cosine is tangent x. And so now I'm done. Left hand side equals right hand side. And so I guess just to reiterate what we did here was we recognized a situation where we could multiply by the conjugate to get our Pythagorean identity involved. And I think once we got to that point, everything kind of fell into place like it normally does when you use your Pythagorean identities. Now I think there's probably several other ways through that particular identity, but my whole goal was to show you how to multiply by a factor of 1 or a fraction of 1 to change the form of one side of your equation. Alright, let's go on to an additional one. Let you look at that one for a second. In fact, I'll give you about 10 seconds here. And think about what side are you going to attack first. Well, I don't think it's quite obvious at this point. And one of the things you can do, and I think that's what we're going to do in this particular problem, is everything we've looked at so far has always been about working on one side, transforming it so it looks like the other side. But another technique is to work with both sides together and get them to end up equaling the same thing. And that's the technique I'm going to use here. On the left-hand side, I'm back into that situation where I can take this single fraction and rewrite it as a sum of fractions with the common denominator. Very similar to what we did last proof. So 1 over the cosine of t plus cosine of t over cosine of t equals, now over here, tangent squared. Anytime I see a square term in a trig identity or trig problem, I'm looking at Pythagorean identity. Now, it's not one of the more common ones, but we do have a trig identity that says, or a Pythagorean identity that says tangent squared t is equal to secant squared t minus 1. Alright, so I'm going to bring my denominator down. And what I'm going to do at this point is take this numerator, which is a difference of squares, and rewrite it as a multiplication of conjugates. And so it's going to be secant of t plus 1, secant of t minus 1. Boy, I didn't give myself much room to work with there. Alright. Now, the reason why I did that is both numerator and denominator have a factor of secant of t minus 1. Factors can cancel. And so what I'm left with on the left-hand side, might as well keep this in red, is secant of t plus 1. And if I go back on the left-hand side, 1 over the cosine t can be rewritten as one of my reciprocal identities, secant t, plus cosine over cosine is 1. So hopefully going through 4 of these gives you some techniques that you can use as you go in and start trying to prove your own identities. I can guarantee there'll be times when you just get stuck. And remember what our third suggestion was. Get everything into sines and cosines and see what happens. See if you can get some things to cancel. Good luck. Let me know if you have questions. It's up to you to make sure that you're getting your questions answered.